We have to revise the logic and controls. This is also very important for you for the exams. You definitely will have to have some questions from the logic gates and the logic circuits. So then we'll discuss. I will revise what we studied in the lecture. Actually, especially we have to understand the basic logic gates, derived logic gates, special logic gates, truth table of the gates, and the universal logic gates, that is NAND and NO. Then here you have to understand the circuit diagram as well as truth table. This is a must. So basic logic gates, actually we can give these three, not AND and O, derived NAND and NO, and XO and XNO gates. NOT gate is normally called the inverter. Inverter is very simple. That is, if you input a certain value, you can get the inverse value of the from the gate. That is, if you enter the 0, you can get 1, 0, 1, 1, 0, 1, 0. Likewise, this is called the NOT gate. Actually, NOT gate is very simple. Here you can see the circuit diagram, and if you input 0 as A, you can get output as 1. If you input 1, you can get 0. That is why inverter, right? A output is can be written as A bar. So this is the basically you have to understand that gate. And AND gate, AND circuit with 2 or more inputs and single output. You can have the 2 or more inputs and you can get this one output. The output of AND gate is truth table if and only if each of its input is also through the true state. Actually, this is very important. Output is 1 only if the A and B is true, that is 1. In other cases, you can see that 0. That is, normally we write A dot B. A dot B. A into B. If the value is 0, 0, 0. If one value is 0, that is 0. If both values are 1, that is 1. So normally we write this output as A dot B. OR gate also simple. If one output is true, in the OR gate, if one output is true, if the one input is true, output is true. Here you can see if both inputs are false, that is 0, 0, output is false. Otherwise, it is true. This can be indicated as A plus B. 0 plus 1 is 1, 1 plus 0 also 1, 1 plus 1 also 1. So, AND and NO gate, NAND and NO gate. So, consider that for the AND gate, the output is going through NOT gate. Output is going to the NOT gate. In such case, you can see the output is like this. The earlier the 0 value becomes 1 and 1 value becomes 1. If both inputs are 0 or one input is 0, output is 1. Otherwise, if both output is true, output is 0. NO gate. NO gate also, for the O gate, output is going through a NOT gate. A plus B bar. That is 0, 0, 1. Otherwise, 0. If one input is 0, output is 0. If both inputs are 0, output is 1. And you have to understand A bar plus B bar not equals to A plus B bar. So you have to understand that XOR gate, normally called the exclusive OR gate. XOR gate, the exclusive OR gate acts in the same way as the logical either or. Logical either or. So then here the output is true, that is output is 1 if either but not both, either but not both inputs are true. The output is false if both inputs are false or if both inputs are true. You can see. So if the both inputs are same, that is false or true, output is 0. If both inputs are 0 or both inputs are 1, output is 0, otherwise output is 1. XOR gate. XNOR gate, exclusive NOR gate, gate is combination of XOR gate followed by an inverter. XOR gate followed by an inverter. That's why put this one. So understand the difference of this one. XOR gate, both inputs are same, output is 0, otherwise output is 1. XNOR gate, then that means the output is given through the going through the NOT gate. In such case, if both inputs are same, output is 1, otherwise 0. Here you can see, if both inputs are same, 0 0 or 1 1, output is 1, otherwise output is 0. So then you can get the summary of all the gates: OR gate, AND gate, NOR gate, NAND gate, and XOR and XNOR gate. Here likewise you can get universal NAND and NOR gates. What are these universal NAND and NOR gate? Universal NAND and NOR gate. Basic gates can be derived using the NAND and NOR gates. So basic gates, we have used the AND OR gates can be derived from the NAND and NOR gates, and it has identified that NAND gate can be replaced by NOR gates or and otherwise. NOR gates can replace by the NAND gate. Here, NAND and NOR version of the NOT gate. If you write here, the both inputs are same. Both inputs are same. That A bar. Both inputs are same here. NAND and NOR version of the OR gate. So having these three gates, NAND gates, we can get the output of OR gate. Here, using this NOR gate also, we can get the NOR gate output. These are actually some versions of the NAND and NOR version, but here you can, when you see this one, even if you can get the A and B output from one gate, but here you have to use the three gates. You have to use two gates. Here also, this is also AND gate. To get the output of AND gate, here it is used two gates. Likewise, we can get the AND output AND O and output no O values by combining the different logic gates. But designing of the logic gates is not using the large number of gates and design the circuit to get the required output, but you have to think how to design a circuit to get the required output from the minimum number of logic gates. So let's see the next lesson of the logic gate. second part of the logic circuit. We have discussed these things the previous lesson, so I am not going to explain once again. Here you know these things, because then combinational circuit and the sequential circuit you will understand. Combinational circuit, logic circuit can be categorized as the combinational circuit and the sequential circuit. When you you are using these combinational circuits and also the sequential circuit with some electronic and other devices. The combinational circuit consists of input variables, set of logic gates, and the output. And the most important feature when you consider the combinational circuit, the most important feature is that the output is ready when the inputs are given. The output is based on the input, not having any other input. So if you input, you can get the output. So we mainly we may have several inputs but only one output, and has no memory element here, the combinational circuit. The combinational circuit is very simple. I will show you the diagram here. N inputs and M output. So the output is depend on only on the input. The sequential logic circuit. Sequential logic circuit, actually output depends not only the current input, but also the past input of values. So that means from the past input, the output is saved in a memory element, and the next time when you input the data with that input, the state that the circuit has saved before in the memory element will be given with the new inputs in order to get the output. Need some type of memory. That's why need some type of memory to remember the past input values. Here, this inputs, the combinational circuit we can find. The output is, state of the output is saved in a memory element, and with the new inputs, this state will be given to the combinational circuit in order to get the new output. So this is the main difference of the combinational and the sequential circuit. Sequential circuit has memory element to keep the state of the previous inputs, and it will enter with the new inputs of the to the circuit. Here you can find this type of combinational circuits, and so option 1, simplify the combinational circuit using the truth table. So we firstly have a problem to be solved. So this could be a problem of having so many variables which are binary, and also we usually call these variables Boolean variables, and they are only two distinct states, that is zeros and ones. Because the computers can only understand zeros and ones, we can also have the zeros and one. This is the procedure to solve that problem. The problem is analyzed. You have to analyze the given problem well, and using after that, if possible, please derive the truth table. And using the truth table, the circuit is built. Using the truth table, circuit is built. I will explain how to build it. There are two methods. So when you can build the circuit, but you don't know whether you have used the minimum number of logic gates for the circuit in order to get the required output. Because when you use the more gate, that means your circuit is host, your circuit is not efficient, as well as you will have to spend more because you will have to buy the logic gates to uh, design the circuit, so that you, after understand the problem and derive the truth table, you have to simplify the combinational circuit. So there are two methods to simplify. One is Boolean algebraic method and Carnot map method. Using these two methods, you can simplify. After simplifying, you can design. You can develop the logic circuit and digital logic circuit or the combinational circuit. Then it will give the required output, so that you can save the cost as well as increase the efficiency and ultimately develop a good combinational circuit. Two imports so then we'll understand. First, we have to have a problem to be solved. This could be a problem of having many variables which are binary, and we have understood. Let's try to understand the Boolean algebra. There are two methods which I explained: Boolean algebraic method and the K-map method. Let's try to understand what is this Boolean algebraic method. Boolean algebra, actually I am not going to explain the history of this one, because I explained actually the George Boole introduced this 1854 and known today as the Boolean algebra. To respect him, the Boolean name is there. The Boolean expression. So Boolean algebra is an algebra for the manipulation of objects that can take only two values, the binary values. What is this Boolean expression? Boolean algebra has a set of operators. You know that when you write a certain expression using these variables, you can have the set of operators: A, B, C, D, A, B bar, C bar, D, A bar, B, C bar, D. Likewise, you can have certain set of combination of operators. Actually, later you will be able to understand. There is a one word for that one, the miniterm. The characteristics of the miniterm, you can't find the same variable name twice, either inverted value or not. So you likewise A bar, B bar cannot be in one miniterm. A bar, B, likewise. Okay, Boolean algebra has a set of operators. Combining the variables and operators yield the Boolean expression. There is a set of rules, so which I explained. I remember we did those things with some examples, but today we don't have time to do that one. Just I revise, and you will have to once again go through these lessons 2-3 times to understand and keep all these rules in your mind. Minimization of the combinational circuit. First, when we first obtain the Boolean expression, it may not be the simplest. You don't know whether this is the simplest version. From that, the same function would, because you can get the required output. So there may be simplified way to present in the same functionality. Because then, when you simplify that, you can reduce the number of gates you want, and you can efficient the process, and you can get the output. Same output. The way of finding the letter is called the simplification of the Boolean expression, and that in that minimization of the number of gates would be also achieved. Here, without explaining actually these things, you can easily understand. To simplify the digital circuit, we can use laws in the algebra. These laws are very, very important. The commutative law, A plus B equals B plus A dot B, B dot A. Associative law means A plus within bracket B plus C is equals to within bracket A plus B plus C. A within bracket B dot C equals to A B dot C. Okay. Distributive, that means you can remove these parentheses. A within brackets B plus C, we can expand it AB plus AC. Independent law means A plus A is A dot A also the A plus A and A dot A is the same. Okay, absorption law means A plus AB, A plus AB. We will show you A plus AB equals A within brackets A plus B, that is AA means AB, A plus AB, that also A. Okay. Identity law for the and O gates, A plus A is A, 1 dot A also A. If A is 0, output also 0. If A is 1, output is also 1 likewise. The whatever the value for the A, we can get A. If A is 0, this becomes 0, A 1, this becomes 1. A plus A bar, whatever the value of A bar, that is 1. If A bar is 0, A is 0, A bar is 1. If A bar is 1, A is 1, A bar is 0. So it will not influence for the output, that is 1. A dot A bar means 0. If this value is 0, that is 0. If this value is 1, that is also 0, because A dot 0 dot A. AND gate, if one input is 0, the output is 0. Inverse value, A plus A means 1, A dot A means 0. So this is the laws which I explained. Can prove it here. A, B, C, A plus B plus C. Likewise, you can get using the gates. I explained this. The output is AB. This output also AC. We can get the summation of X, that is AB plus AC. This X, here you can see A dot B plus C. We can see A dot B plus A dot C. Then A dot B plus A dot C, AB and AC. A within B plus C also this. Rules of the Boolean algebra. These rules are very, very important. From 1 to 6, you can get for the O gates. 7 to 12 is similar to the AND gate. So A plus 0 is A plus 1 is 1, A dot 0 is 0, A dot 1 is A. If when you put the 0 for the A, this is also 0. If you put a 1, this is for the 1. A plus A is A plus A bar equals 1. A dot A is A dot A bar. Whatever the value of A bar means inversion, invert value, that is 0. A double bar, that means when you use two NOT gates, that is A plus AB, also A plus A bar B, we can prove that A plus B, and this is A plus BC. Here rules also given like this. The above mentioned rules can be given rules 1, 2, 3 likewise for the AND gate, OR gates and the AND gates, or both. We can get, when you apply 2 times, then you can get once again 0. This becomes 1 and 1 applies 0. That means, so from the truth table also you can see A plus AB equals A. So A plus AB you can get 0, 0, 1, 1. So you can get A value also 0, 0, 1, 1. This is equal. Anyway, we'll understand how to simplify using the Boolean algebra. You have to apply the law. If you are given A plus AB, you can get the A 1 plus B. This is the distributive law you have applied. 1 plus B equals 1. Whatever the value of B, output is 1. And A dot 1 is A. Likewise, you can prove it. Here is given simple example. A double A plus AC plus BA plus BC. Double A you could get when you remove the parenthesis, and you can write likewise. Here AA AC plus BA plus BC, and once again you can get the A 1 plus C, that is 1. BA BC, get the B plus C. Here you can see, and from these two get A 1 plus B and BC. 1 plus B is equals 1 BC, A plus BC. Likewise, if you can write the rules you applied to simplify this one. When you simplify this, when you have the circuit of this one, and you can get the output, but the same output can be given by using this. So then I discuss some review questions also. De Morgan theorem. De Morgan theorem says, remember how to memorize this one. Break the bar, change the operator. This is the main thing you have to understand under the De Morgan theorem. Break the bar. The bar is this one. Change the operator. You can write x bar dot y bar. X bar dot y bar, x plus y bar, and also x dot y bar can be written as x bar dot plus y bar. Break the bar, change the operator. De Morgan theorem also very important to apply. The whatever the value we can write like A, B, C up to n. We can write A bar plus B bar plus C bar plus up to the n. So we have done some examples in the class. From this circuit we try to simplify to this one, and this uh, this expression we try to simplify a plus b plus c, a within bracket b plus c. Here some examples I explain of this one, and next K map. After explaining the K map, I will discuss some questions. K map, also Karnath map. I am not going to explain the history. Actually, this also used. This is the Boolean algebra is the mathematical method to simplify the circuits. But the K map is not the mathematical method. Actually, this is called the pictorial method that we can use for simplifying the logic circuit, so that you have to understand there are some rules, actually altogether 7 rules that we have to follow while we are simplifying using this K map. That there are some terminologies. First of all, you have to understand the K map is a matrix consists of rows and columns. We are going to draw this Boolean expression in a certain table diagram. So the output value is placed in each cell and derived from the miniterms of the Boolean function. So what is this miniterm? Actually, miniterm is a product term that contains all the functions variable exactly once, either complemented or not complemented. That means you can't find the a bar, b bar as one miniterm. The variables can appear only once, either complemented or not. Here we can see simple example xy. We have been given xy plus x bar y. Xy plus x bar y. We know that if there are two variables, we can have the output 0, 0, 0, 1, 1, 0, 1, 1. That means if there are two variables, the maximum miniterms we can have 2 to the power 2, 2 to the power number of miniterms, that is 4. So then today, if there are three variables, x, y, z, the maximum miniterms 8. Here you can write the possible potential miniterms if there are three variables. Here are the potential miniterms: x bar y by z bar, x bar y by z, x bar y bar, x bar y z bar, x bar y z, x y by z bar, x y by z, x y z bar, x y z. Here you can see. You can easily derive the truth table for these miniterms. The first, put the three variables x, y, z. Then first variable 4 zeros and 4 ones, and the second variable 2 zeros, 2 ones, 2 zeros, 2 ones, and final one is 0, 1, 0, 1. Likewise, then you can get the combination of this one. X bar y by z bar. Here x bar y by z bar. Then here x bar y by z. Then x bar y z bar. Likewise, you can get. If there are 4 variables, 16 miniterms you can have. And you can draw this this given miniterm, given expression in a K map. Put the variables here, put the variables, and you can draw like this. If you can draw this one as 0, 0, xy is 0, 1, 0, 0, 1, 0, 1, also 0, 1, 1, 1. That is xy x value is 0, y value is 0, output is 0, x value is 0, or y value is 1, that is 0. If y value is 0 and x value is 0, 0, then if both values x and y values are 1s, then you can get the 1. Likewise, in the given miniterm, you can draw this here. If you are given a miniterm like this, x bar y, xy bar and xy, you can see it like this. X bar y, x bar y, here 1. You can mark, if the miniterm is given, you can mark as 1, otherwise you can mark as 0. Xy bar, that also 1. Xy, yes. Now, but x bar y bar hasn't given. In such case, you can put the 0. How to simplify? When you are going to simplify, you have to group the ones, not the zeros. Group ones. Then when you are going to group ones, there are set of rules. Let's understand the rules first. Group containing only elements containing 1. You can group only 1. So no, you have to select only ones, not the zeros. Second one is only horizontal and vertical grouping, diagonal are not allowed. If the one is likewise, you are not allowed to group like this. You have to group horizontal and the vertically only. Horizontal groups and the vertical groups only. Third one is group always the power of 2. That is 2 to the power 0. 2 to the power 0 is the group can have with the 1, and also 2 to the power 1 is 2, having 2 ones, having 1 1 and having 2 ones. 2 to the power 3, 2 to the power 2 is 4, and 2 to the power 3 is 8. Likewise, group powers of 2, always powers of 2, 0, 1, 2, 3, 4, likewise. That means if there are 3 variables, you are not allowed to mark, and also even though this is 8, but you have to group only ones, not the zeros. In such case, you can't use this one also, because with the zeros you are not allowed to group. Here you can group like this, but you are not, this is correct and this is not correct, even though you can mark the groups with the 2 to the powers, but there is a one, each group should be large as possible. So each group should be large as possible. Even that is why you can, even though you can mark 3 simple groups, you have to, this is wrong actually, you have to mark having large group should be large as possible, having more ones. Okay, and also the group can overlap, groups can overlap like this. These two will be used, this group and this group. So and also group may overlap, that means these two are used, this group and this group, that is okay. And groups may wrap around the table. Group may wrap around the table means by getting the corners. For an example, consider that there is a K-map that have the value 1, 1 and this also 1, 1. In such case, you can group as like this. That means you can wrap, when you fold and connect the two edges, you can create a cylinder, and in that time the ones will come together, so that you can group as like this. So should have fewer groups, should have fewer as possible. You have to mark the few larger groups. That means not allow the small groups, large as possible. So these are the rules, and simplification of three variables. Sometimes we have two variable Boolean expressions, three variable Boolean expressions, as well as four variable Boolean expressions. In such case, you have to understand how to simplify using the Boolean algebra. Here, if there are three variables in your diagram, you can put x, y, z. This is very important, how to give the marks, that is 0, 0. X can be, x and y value can be 0, 0, 0, 1 and 1, 0, 1, 1. Note that is wrong. 1, 1 and 1, 0. 1, 1 and 1, 0. Four mini terms are there, 0, 0, 0, 1, 1, 1 and 1, 0. X value is 0, 1. Okay. Then you can easily marks if there are mini terms to satisfy this, put 1. If there is no mini terms for this one, put 0. 1 and 0. Let's see. We have been given like this: x bar y by z, x bar y z, x y by z and x y z. Let's mark together: 0, 0, 0, 1, 1, 1 and 1, 0. This is very, very important in your exam also. 0, 1. So here when you get this one, x bar y bar z, x bar y bar z, x bar y bar and z, this one is 1. X bar y z, x bar y z, this also 1. X y bar z, x y bar z, this is 1. X y z is this one. Then when you want to group this one, you can create two small groups, but you can create one large group. So while you are creating the one large group like this, you can write the mini terms of this one: x bar y bar z, x bar y z, then x y bar z and x y z. When you write these things, you can write there are some variable that has been changed and there are some variable that has not been changed. The changing variables through that group can be cut, and the remaining, the variables that has remained unchanged through this group, it can be get as the variable of this. Then next one is also three variable expressions example. And here when you are going to group, you can wrap around the table and create this one. Overlapping is it's not a problem. Then K-map simplification with four variable. So four variable, how do you mark this one? Wx, yz. Wx value 0, 0, 0, 1, 1, 1 and 1, 0. Yz value also 0, 0, 0, 1, 1, 1 and 1, 0. Then altogether 16 variable. Mini terms are there. Here you can mark these mini terms like this. Plot. And when you group, how many groups can you create? If you group correctly, you can create these groups. By getting the corners together, prepare one group, and this one also what we call the rollback, rolling the graph, and this there are three groups. So having three groups, you can select x bar y bar plus x bar z bar plus w bar y z. This is the answer, simplified version of this one. For this one, rather than writing this, you can get the same output from this also. Then you can minimize the gates as well as okay. Then so then start. Then we can group. We can group like this. Okay, we can group like this. Then get the four corners together and huh? And wrap around the group. Create the large group like this, and these two can be grouped as a another group, so that we can get the simplified one is x bar y bar plus x bar z bar plus w bar y z bar. Instead of this expression, this 1 2 3 4 5 6 7 mini terms, we can get the same output from these. That's why the simplified version. K-map simplification, actually K-map simplification for 4 variables. It is possible to have choice of the as how to pick groups within the K-map while keeping the groups as large as possible, so that you can see the same problem can be grouped in two ways. The different functions that result from the groupings below are logically equivalent, so that you don't worry about it. It's logically equivalent. So this also the three groups, this also the three groups, maximum of 4 variables, one group 1, and 2 variable groups 2. Okay, then one of an important thing is to understand the don't care condition. This condition is very, very important because when you are grouping, if the problem is given the don't care conditions, you can mark as cross mark the don't care condition. In K-maps, the don't care condition is identified by the X and is called the mini terms for don't care inputs, as shown below. Say here you can see. So what is the advantage of having this don't care condition? And it is performing the simplification. When you are going to group, we can either include this don't care mini terms, or we can there isn't any rule to include or exclude. But if you want to create the larger groups, you can use these don't care condition mini terms. Likewise here, these two can be taken to create these larger groups, and for the creating the mini terms, the don't care condition can be considered. So this is very, very important, the don't care condition, and simplify the version. Then finally, once again, before doing an example, replace a rule by K-map simplification. Group can contain only ones, not zeros. These are the 7 rules. Group can be formed only the right angles. Diagonal groups are not allowed. As I explained, diagonal groups are not allowed. The number of ones in a group must be the power of 2, even if it contains a single one. That means 2 to the power 0 is 1. The groups must be made as large as possible, and group can overlap and wrap around the side of the K-map, and use don't care condition when it is needed. So that's all for the logic circuits and the K-map. So let's see some exam questions related to this, revision questions. Here, simplify for the Boolean expression using the Boolean algebra and De Morgan theorem. So, you will have a Boolean expression to simplify. How do you simplify? So, I will give you 10 minutes time. Please try to answer this one. Simplify these two Boolean expressions and answer the following question using the function given below. This is the function. Actually, this is x bar y bar z. Bar has shifted to the left side. So derive the truth table for f. So derive the truth table for f. Draw the logics diagram using the original Boolean expression. Simplify the expression by Boolean algebra and identities and draw a logics diagram for the simplified version. So then try to do these two questions to 5 and 6 within 15 minutes time. Okay, I will give you time. Sometimes you will be given the digital logic circuit simplification like this. This is also very important to understand this way. Output of the digital logic circuit is given by the following Boolean function. F w x y z, that is the summation of mini terms. This is called the summation of mini terms 0, 1, 4, 6, 9, 11, 13, 15. Okay, this 0, 2, 4, 9, 0, 2, 4, 6, 9, 11, 12, 15. In such case, how do you derive the truth table and determine the output of the above Boolean function? And sometimes the don't care condition also will be given, like something like this one, don't care condition. Care condition, and also will be given summation of this mini term one, 5, 14, likewise for an example. So how do you derive the truth table and how to get the sum of product? Sum of product I will explain later. Then how do you get this one, mini term? So in such case, you can use let's say, let's get a new document, and okay, no need to get the new document, we'll explain from here. Here insert table. Something like, let's the number, sorry, first take number, this is w x y z and f. Okay, number is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 and 15. So why I get 15? Because there are only 4 variables. When you get the 15, when you convert to the binary, 15 value comes 1, 1, 1, 1. From these 4 values we can represent the 15. So that's why I get onto the 15 as it will given 4 variables. Then we can write 0, 0, 0, 0, 0, 0, 0, 0, then 1, 1, 1, 1, 1, 1, 1. So these are the potential values for W. 8 zeros and 8 ones. The second column, 4 zeros and 4 ones. 0, 0, 0, 0, 1, 1. Sorry. 1, 1, 1, 1. Once again, 0, 0, 0, 0, 1, 1, 1, 1. Okay. Then the third variable, you can write 2 zeros, 0, 0, 1, sorry, 1, 1. Once again, 0, 0, 1, 1, 0, 0, 1, 1, 0, 0, 1 and 1. The final one is 0, 1, 0, sorry, 0, 1, 0, 1, 0, 1, 0, 1. Zero, 1, 0, 1, 0, 1 and 0. So these are the potential values for W, X, Y, Z. So here in this case, the summation of many terms have been given like this: 0. The number 0 has 1. Here we can put 1. And 2 also has 1. 4, 3, 4 also has 1. 6, 5, 6 has also 1. And 9, 6, 7, 8, 9 also has 1. 11, 10, 11 has 1. 13, 12 and 13 also has 1. Then 15 also has 1. And don't care condition is given 1, 5, 14. 1, we can put cross 1, 5 and 6. 6 is 1, 1, 5, 14. 14 is given this one. Then others can put the 0. 0, 0, 0, 0, 0. This is the truth table. You will have to truth table determine the output of the given Boolean function. And here you can write the truth table. Then you have to write the mini terms for the ones. Mini terms for the ones. How do you write the mini terms? I am not going to write. Then you can write the F is W bar, X bar, Y bar, Z bar. W bar, X bar, Y bar, Z bar. Then second one is 2 W bar, X bar, Y, Z bar. Third one is 4 W bar X Y bar Z bar. Fourth one is 6 W bar X Y Z bar. And next one is 9, I think 9 W X bar Y bar Z. Likewise, select the ones and write the miniterm using W X Y Z. Okay. Then you have to simplify using the 4 variable K map and put that one in a K map. Then you can write the function here, Boolean expression, and using that Boolean expression you have to fill it in a 4 variable K map, like using the diagram like this. We'll see no, this is not given, that one, and we'll see the past paper of the last. Here you have to plot this one. Then you can create, you can get the function from that like this, and the don't care condition is also given. In this paper, actually, one step note is going to give from this one, and the question did not start from this point. The question starts from the Boolean expression, and you can plot that miniterms in the function, and don't care conditions also you can put that one, and then you can create the group having this following these rules and minimize. So you can minimize, the answer is this one for this question. For this question, but in this question the function is given, but here in this case you have to derive the function using this one. You have to derive the function using these two, so that you have to have a truth table like this for the values, because these values can represent from the 4 variables. That's why we have been given 4 variables x, y, w, x, y, z, and derive the truth table like this and write the Boolean expression. After getting the Boolean expression correctly, you can simplify like this. You can get the K-map and simplify. This time there is one question for this. You can get 10 to 15 marks. So that please prepare for this. So the Boolean simplification as well as this K-map. Okay, then today actually I wanted to explain the K-map things as well as simplification, and finally I will explain how to get the sum of product form, SOP and PO, product of sum and sum of product. That is very, very easy. So sum of product. So after completing this module, you will be able to understand logic circuit design process, sum of product and product of sum. Actually, sum of product and product of sum is very, very important. Then you derive the logical expression and simplify. The SOP form, sum of product form, when you see this one, you can have the set of AND gates, and all these AND gates are combined to the OR gate to get the final output. And when you simplify this, simplify the expression, you can get the sum of product. Write the AND term for each input combination that produce one output. So you can see you have had this one. SOP logical expression is this here: A bar BC, then A B bar C, A B C bar, and A B C. This is called the sum of product. Deriving the logical expression, then you can get the product of sum also. Conjunction normal form. Conjunctive normal form is called the product of sum. Maybe when you were in the A-level classes, you have studied how to get the product of sum also from the K-map. That means you are going to group not the ones, zeros this time. Zeros this time, and when you are going to group, you have to follow the same rules, same 7 rules. Group for the zeros, not ones, and you have to create the groups as large as you can. And zeros of the 2 to the power 0, 2 to the power 0, 1, 2, 3 likewise, and diagonal groups are not allowed. Likewise, all the set of rules you have to apply. Then the one difference of the product of sum and sum of product and the product of sum is, when you write the many terms, you will have to write the inverter value with the plus mark. For an example, if you group, let's see, I will explain. Not example also not there. Anyway, when you group and when you write the many terms, A, B bar, C bar, D bar, not like you are right. If it is A, actually value the A bar, you have to write A, the inverter value, plus B is there, not the B bar. If you are going to write the B bar, plus C, and mini term is not the plus mark, that is the dot. So likewise you can write. Let's see how to get the product of sum. Here you can see the sum of product here. Deriving the logical expression, product of sum, conjunctive normal form you can get, having the OR gates, and finally you can get the AND gates to get the product of these 4 mini terms. So get that is, F is A bar, A B C. Instead of the these values, you have to write the inverter values, A plus B plus C, and A B C bar, and A B bar C, and you finally A bar B C plus C. So when you apply the De Morgan theorem 2 times, that is break the bar, change the operator 2 times. De Morgan theorem 2 times. Start from the sum of product A bar BC, A bar BC, sum of product, and you can get the product of sum. Let's try to how to do this one. This product of sum from the sum of product. So sum of product and product of sum. So then you can put these bar values and ABC, ABC, and F dash is F dash, F dash, F dash, F dash. This is A dot B dot C plus dash value when you get A bar B bar C. Likewise you can get. Apply De Morgan theorem 2 times. When you apply the De Morgan theorem, F double bar is F. Then break the bar, change the operator. This plus becomes dot, and you can change from this each mini term. ABC dot AB A bar B bar C bar. Likewise you can get. Then once again, when you apply the De Morgan theorem, break the bar, change the operator, that A double bar plus B double bar plus C double bar, that is ABC dot A double bar A, B double bar B, C bar. C is here only C bar dot A double bar A, B is here no any bars, that is B bar, and C double bar is C. Likewise you can get the A, B, C. So applying the 2 times of the De Morgan theorem, you can get the product of sum. So that is so then you have to understand how to get the sum of product form. For the exam, the sum of product is very, very important. This time I am not going to check the product of sum, so that you have to understand how to get the sum of product from the truth table. That's all. So then I discussed today 3 lessons: digital logic circuits, gates, as well as sum of product and the product of sum. The